Today's topic is kinematics. If we said kinematics, we need to know what it is, what kinematics is. Now, kinematics is a field of physics which deals with motion. If we said motion, we need to know what a motion is. Now, the motion is the change of an object's position with respect to a certain reference system. For example, a rectangular coordinate system. And simultaneously, if we said motion, we need to know how to divide motion, what kind of motion we have. In general, we can speak about a forward motion, when a body or an object moves forward. And that forward motion we can divide with respect to the trajectory and with respect to the velocity. If we take into account the trajectory, the forward motion can be divided into rectilinear and curvilinear. Rectilinear, when a body moves in a straight line. Curvilinear, when a body moves, for example, in a circle, in a curved line. And now, both of these motions can be further divided into uniform and variable, this time with respect to the velocity. Uniform, when the velocity doesn't change, when the velocity is constant. Variable, when the velocity changes. The uniform motion cannot be divided anymore, whereas variable motion we can divide into uniformly and non-uniformly motion. What does it mean, uniformly? It means that still the velocity changes, but that change is proportional to the time. If you are speaking about non-uniformly motion, that change is not proportional to the time. It is a form of a chaotic motion. Sometimes the body increases, sometimes decreases its velocity, and that change is not always proportional to the time. We are not going to deal with this motion anymore, but the variable uniformly motion can be further divided into accelerated and retarded. Accelerated when the velocity increases, retarded when the velocity decreases. And now we go to discussion of each of those motions one by one. At first, rectilinear uniform motion. In general, if we are speaking about a certain physical phenomenon or a physical field or field in physics, we need to have a certain tools in order to describe that phenomenon or that field we are speaking about. Such tools are so-called physical quantities. For example, if we are speaking about a rectilinear uniform motion, we have three quantities: velocity, time, and distance. Velocity v, time delta t, and distance delta s. Instead of distance delta s, we sometimes use a term displacement, the displacement delta r. In most cases, when we are dealing with a vector form. And now we need to know the interrelation between the three quantities: velocity, distance, and time. The interrelation is over here. In order to calculate velocity, we need to take the distance and divide by the time. At any time, we can convert this formula. For example, we can calculate delta S, which will be done in a moment. But on the occasion, this form, as a so-called scalar form, can be rewritten into this form, which is a vector form, because velocity and the displacement can be treated as vectors. Then we use this form. But in general, if you want to calculate the value of values, you are using this form. And this form, this formula, is nothing but a mathematical function. If this is a function, then we can draw or plot a graph. For example, distance versus time. Because this is a uniform motion, meaning the velocity is constant, it means also that the interrelation between the path or distance and the time is proportional, and the graph is a straight line starting from the origin of the coordinate system. Let's say we've converted the previous formula v equals delta s over delta t in order to find the distance delta s. Upon conversion, the distance formula is delta s equals v times delta t. The delta symbol has been dropped for better transparency. Anyway, here we have the distance formula, or the formula in order to calculate the distance. Simultaneously, if we have such a formula, again, we have to do with a function. If a function, then we can draw or plot a graph. For example, velocity as a function of time. Because the velocity is constant, the graph is the straight line which is parallel to the time axis. Let's say we started our observation at the time t1, and the terminal time, we finished our observation, the terminal time is t2. So our graph here is from this point to this one. What can we notice over here? This is a rectangle. If we want to calculate the area of this rectangle, we need to multiply side by side. But simultaneously, we know that this side is t2 minus t1, in other words, delta t. And this side is our v0, or in general v. So if we multiply the two sides, we'll obtain this area, the rectangle area. And simultaneously, we notice that v times delta t is nothing but our distance. So the conclusion is the figure under the graph represents the distance covered by the moving body or the moving object.